Okay, so this is an absolute value equation. The absolute value in this case is of that of a quadratic. So the argument in this side, this absolute value, is quadratic. And it's equal to this linear function here on the right. Taking a look at the graph, the normal quadratic function would come down through here and up like that. And there should be a intersection point right there where it normally would be equal to it. However, we're doing the absolute value, so rather than having this line, this will get mapped up here. All those negative y values get mapped above the x-axis. Can't have negatives in absolute. So we introduce this new point right here. That will be a new intersection point. So again, for the solution of this equation, you got to find those two intersection points. And in order to do that, you need to solve the absolute value equation in a piecewise manner. And what I mean by that is you have to solve for the positive case, where you just use the original argument in its positive sense, like as is. You don't make any changes. So you just solve it as if there was no absolute value symbols. The other case is the negative case. So in other words, you have to apply a negative to the result of this function. Like after this function is completed, you'll get a number that's a y value. Now and you know that down here, when you on this region of x, for all these x values, you're going to calculate a negative y. So if we tack on a negative, it's going to come up here. So that's what we want to do. All you have to do is tack on a negative. I'll put it down here. And solve this equation as well. So for the first equation, rather than dealing with fractions, let's just multiply by 3 on both sides and expand this brackets. So I'll expand the two binomials here using distribution. So I have an x squared minus 3 plus 5 is a positive 2x, and minus 15, and that's equal to, here on the right side, if we multiply by 3, negative 3x minus 9. Continuing on with the algebra, we arrive at this, which has a solution of this. So x equals minus 6 and positive 1 are the solutions to this first equation. And we take a look at the graph. When x is minus 6, we get this point here. So definitely we know that we're going to need this value here, x equals minus 6. Now take a look at this other value, x equals 1. When you analyze that spot, it looks like it's right there, x equals 1. That's where the old quadratic would have been equal to that spot. So when you take the absolute value, we lose that negative answer. So we have what's called extraneous solution. And I'll just put extra for short. Okay, so from the first equation, we're able to arrive at one of our answers, the one arrowed on the graph here. Now we have to take the negative version to try and find this intersection right there. So I move to the algebra on this next equation, and I'll expand the two brackets here as x squared minus 3 plus 5. I've done this already once before, plus 2x minus 15. And on the right hand side, we'll multiply by a positive 3. And that will cancel this fraction here. So multiplying by positive 3, you get, or pardon me, by a negative 3, you get positive 3x and a positive 9. So we multiply by a negative 3 on both sides, which cancels this fraction here. Okay, so we isolate the x's on one side and solve this quadratic. You take a look at this quadratic, two numbers you need to multiply to 24 and add to 1, so you see that you can't factor it, so you go to your quadratic formula. Okay, so to find the solutions to this quadratic using the quadratic formula, you'll have x equals negative b, so that's a positive 1, plus or minus b squared, so negative 1 squared is 1, minus 4ac, 4 times a, which is 1, times c, which is minus 24. Now this negative and this negative will cancel to give us a positive. That's important because the square root needs to have a positive radicand. All over 2a. 2 times 1 is 2. So you can see here that x is going to be equal to a positive 1/2. Okay, 1 divided by 2, 1 divided by 2, plus or minus. Now we simplify the radicand. 4 times 24 is 96, plus a 1 is 97. 97 does not have any perfect square factors, so we can't simplify it. So our x values are just 1/2 plus or minus 97 over 2. Here are their decimal expansions. So when you take these values and take a look at the graph, you'll have to identify which values are going to work. So clearly the negative answer is going to suffice. Okay, so the answer negative 4.42 will give us that correct x value. So we've solved the equations. You have two extraneous solutions, one there and one there, and the other two are the actual. Thank you.